Now, since we're using reduction formula since for a while now, we understand what this means. Where in is equals to minus 1 over n sine raised to power n minus 1 x cos x plus n minus 1 over n multiplied by I subscript n minus 2. Now we have a question here which says we should evaluate the integral of 4 sine raised to power 5 of x with respect to x from upper limit 1 down to lower limit 0. And we know that this is equivalent to 4, 0 of 1, 0 to 1 of sine raised to power 5x dx. So the first thing to do is to evaluate the reduction formula of sine raised to power 5 of x dx. So since this is similar to this, that means our n is equals to 5. So which gives us I5. So then we make our substitution of I of n is equals to 5 in this equation. So this will give us minus 1 over 5 sine raised to power 5 minus 1 of x multiplied by cos x plus 5 minus 1 over 5 I subscript 5 minus 2. Therefore, our I5 will be equals to minus 1 over 5 sine 4 x cos x plus 4 over 5 I3. Now we are able to evaluate I5. Now the next thing to do is to evaluate I3. So I3, substituting n to be equals to 3 in In. So wherever we see n, we change it to 3 in this function. And that will give us minus 1 over 3 sine 3 minus 1 x plus x plus 3 minus 1 over 3 I subscript 3 minus 2. So this gives us minus 1 over 3 sine square x plus x plus 2 over 3 I1. So this is an expression for I3. So now we have to evaluate an expression also for I1. So I1, that means our n is equals to 1. So we come back here and make our expression of I of n to be 1. So therefore we have minus 1 over 1 sine 1 minus 1 x plus x plus 1 minus 1 over 1 I 1 minus 2. So they give us minus 1 over 1 sine 0x plus x plus 0 over 1 I subscript minus 1. So this nullifies to give us 0. And we know that sine raised to power 0x can be written as sine x raised to power 0. And anything raised to power 0 is 1. So this gives us minus 1 into 1 of cos x. And we understand this will give us minus cos x. So this is I1 is equal to cos x. Now to get I5, which is the question we are attending to have, we make substitution of I1 into I3 and make substitution of I3 into I5. So now let's evaluate I3 after we have substituted I1 to be minus cos x. So I3 will give us minus 1 over 3 sine square x cos x plus 2 over 3 I1. And we know that our I1 is the same thing as minus cos x. So our I3 is similar to 1 over 3 sine square x cos x minus 2 over 3 cos x. Now we have an expression for I3. We can now substitute this expression into I5, and then we can now evaluate I5. So in this case now, let us rewrite what I5 stands for. So I5 is equals to 1 over 5 minus 1 over 5 sine raised to power 4x plus x plus 4 over 5 I3. So let's substitute I3, and then we have that I5 is equals to minus 1 over 5 sine raised to power 4x plus x plus 4 over 5 of minus 1 over 3 sine square x plus x minus 2 over 3 plus x. Simplifying further, this will resolve into minus 1 over 5 sine raised to power 4x plus x minus 4 over 15 sine square x plus x minus 8 over 15 plus x plus c. Now remember that I5 is equal to integral of sine raised to power 5 x dx. I5 is integral of sine raised to power 5 of x dx. And the original question, which says integral of 4 sine 5x dx, this 4 is a constant, can be brought backwards to the integral of sine from 0 to 1. Therefore, let's apply our limits. So you have 4 into minus 1 over 5 sine raised to power 4x plus x minus 4 over 15 sine square x plus x minus 8 over 15 plus x, limit from 0 to 1. So let's apply our upper limits and also our lower limits. So this gives us minus 1 over 5 sine raised to power 4 of 1 plus 1 minus 4 over 15 sine raised square of 1 plus 1 minus 8 over 15 cos of 1. So this is subtracted by lower limit of 0 minus 1 over 5 sine 4 of 0 plus 0 minus 4 over 15 sine square of 0 cos of 0 minus 8 over 15 cos of 0. Now we know that our cos 0 is equal to 1 and sine 0 is equal to 0. Therefore, this nullifies to give 0, likewise this. So when we apply this into calculator, our final answer will be 0.356.